Hi everyone, and welcome to today's webinar. My name is Jason Walls from QA Cafe. Today we're going to be talking about devices under test that, for one reason or another, require access to external resources, and how it's possible to test them in a lab environment while allowing them to access the external resources that they need. So first I want to talk about what exactly we mean. What exactly we mean when we are talking about these kinds of devices. Cloud managed, resource dependent kind of things, and some examples of products that are out there that do this kind of thing. Secondly, I'll go over the different test setups involved in testing cloud managed devices and some of the caveats of the setup. Next, I'll talk about the CDRouter ICS add-on, and so that's actually how we test these devices. And we'll show how it handles test and application traffic separately in order to enable the test environment for these situations. And then lastly, I'll talk about some of the test cases that are most important to cloud managed systems. At the end, we'll go to questions. We're using GoToWebinar for this, and if you've never used it before, you can type your questions in the question box in the lower right-hand corner of your GoToWebinar control panel. And we'll get to those questions at the end. Also, if you have trouble seeing some of our examples, you can use the zoom feature at the top of the GoToWebinar screen, and you can adjust the size of what you're looking at so that you can see it depending on the size of your screen. All right, let's get started. So what kind of devices are we talking about? These are network connected devices that at some point they need to contact some non-standard external resource. And so why do we say non-standard? Well, we're talking about proprietary systems that are outside the norm of network services like DNS or NTP or even Tier 69, things that can't necessarily be simulated by CDRouter and are necessary for the startup procedure of the device. For example, I say TR69 because it can be simulated, so we don't necessarily need access to a real-world ACS in that case. But in the case where it's dependent on some external resource, how can you still test that? Some of these devices rely on the cloud for their bootstrapping process. They must be connected to a remote server and register with a service or receive configuration information before they can even operate. This presents interesting situations where there are devices that cannot operate when the WAN is down, but barring that design choice, these devices that need to connect to services in order to begin operation, or these are devices that need to connect, and even if they don't later have to communicate with the cloud service, so on Bootstrap. On the other hand, there are those devices that are either remotely managed using some proprietary web interface, they report usage statistics, or they make API calls as part of a custom application. These devices will generate and receive application traffic that needs to reach or is received from the cloud during the period of normal operation. So some of examples of these devices include these sort of cloud managed systems that we're talking about, such as managed Wi-Fi, so things like Meraki, AeroHive, Eero, Ubiquity, and others that allow you to connect to a single web application to manage all of your access points and other network devices. This also includes smart routers, so single endpoints that nonetheless rely on a user-facing application for configuration. And it also includes things like smart hubs and devices that connect to a web service in order to function like home monitoring systems. The other devices in this category are those that the user doesn't necessarily interact with directly, or they can in some cases, but the system is making API calls behind the scenes to operate some service. So this includes things like parental control of network security monitoring applications, or anything that requires auto configuration or bootstrapping through a particular management protocol. So let's take a look at our traditional closed loop test setup. In this case, CDRouter is simulating all of the network services, all the WAN terminations, and the LAN clients. It's also simulating any standardized applications that a device under test might interact with. This should be pretty familiar with, for anyone who currently uses CDRouter. And the thing to note here is that the entire network is simulated, so the DOT never connects to the internet during these tests. And this has its advantages. A closed loop is ideally how we want to test everything because it allows isolation. So in an isolated environment, you won't see any extraneous traffic interfering with test results. And this lets you clearly distinguish your control versus experimental variables in testing. Secondly, it provides for a consistent test setup. So when CDRouter simulates services, you can be comfortable knowing that it is being generated in the same way every time, rather than relying on an existing network setup that may be doing other things, or it may have been running for a period of time that has introduced unpredictable results. And lastly, there's a big benefit of ease of use. Since the WAN terminations and the standardized services are simulated, there's no reason to try to provision these services yourself in your lab or use organizational resources that might have to be shared. So these are the benefits of closed loop testing, and there's the things that we want to preserve. So the question is, how do we pass on those benefits to cloud-dependent devices? So we do this with an add-on called CDRouter ICS, and the ICS stands for Internet Connection Sharing, because as you'll learn, it uses some of the same concepts of an operating system that is sharing its network connections and using similar technology. So what we do in ICS is set CDRouter up just as we would in a closed loop, but we route any traffic that CDRouter knows is not destined for itself. That is, traffic that is not part of our usual test cases or part of our startup procedures. We route that out of a CDRouter interface attached to the larger network. For our examples, we'll call this application traffic as opposed to test traffic. ICS does this by creating an externally facing NAT to separate the traffic, which has some caveats that I'll explain later. So let's see this in action. I have a device that we bought off the shelf that we've already run through some CDRouter tests. And I'm going to show you the packet captures of both the startup sequence and one of our FTP tests that sees some application traffic while it's going on. So let's look at this startup test first. So I'm going to go into the log. And to show you these, I'm actually going to use CloudShark, which is our advanced packet analysis tool. We have both online and enterprise versions, but I'm going to use the online version. So I'm going to go to the WAN capture, and then I'm going to download this. Then I'm going to go to CloudShark, and I've already logged in. And so this is the capture list view, and I'm just going to drag that in here. And so for here, I wanted to show kind of all of the things. One of the things that I'm going to show you later, this ladder diagram, which will show kind of all the communications, but you can see that there are tons of things that this device is doing. So to show you kind of what's going on, I wanted to look at the DNS activity. So when this device comes online, it's contacting all of these things. And that's a pretty strong set of things that it tries to contact in order as part of its startup procedure. And some of the things that stuck out to me are, you see that it tries to, it does a DNS request for Facebook, it does a DNS request for Google, and then presumably it's actually trying to connect to a lot of these things. And we've seen this before. So a lot of these devices, they'll go through sort of this startup procedure where they try to connect to well-known things. And they sort of use that to determine that the WAN connection is working and is active. And it seems, it seems kind of, kind of a weird mix of tools that would use to try to prove this. But this is basically what users do when they turn on a computer and they want to know that their network connection is working. So the devices like this, they they also use that. So this is a lot of stuff, but this is the startup procedure, so it doesn't have any of our test traffic in it. So to show you that, I'm going to go back to this test right here, which is one of our FTP application tests. And I'm going to download this capture. And then also upload that to CloudShark. And I'm actually going to make this capture public so that when I show you the ladder diagram, I'm going to paste it in the chat window here, and you guys can click on it and look at it yourself. So for here, I want to show you, a diagram of the traffic that's going on so you can see the difference. So I'm going to go to ladder diagrams here, and we see everything that's going on. And I'm going to move these around so it kind of makes sense. So I know that, that the IP address that CDRouter assigned was this one over here. I know that this is one of CDRouter's internal services, and these are our DNS, our simulated DNS servers. So I'm going to move this over here so it looks a little better. And now you can see that that order is now part of the URL. So I'm going to copy this. So if you go into the chat window and click on this, you should be able to view it in your own browser and kind of take a look at that. So what's going on here? We see as soon as this test starts, the device under test actually goes and tries to make some sort of call to this server out here. And if we go and kind of do a little bit more analysis, you'll find out that this is actually an Amazon, an AWS instance. So whatever service is being hosted out there, and it goes and it makes this call, and the server responds. And then we see that our test traffic, right? So this is the simulated FTP server. Our test traffic starts right here, and you can just see the direct communication between the device under test and our simulated server. You see some more application data being sent. And then you actually see some DNS requests going out to our simulated DNS servers here. And then some more test traffic. And then at the end here, it's doing all kinds of stuff. So there's an entire communication that's going on here. So maybe the fact that we were doing FTP triggered some sort of communication or some statistics gathering that they wanted to send to these other servers here. So through that, you can see that we are separating the test traffic from the application traffic. So I just want to show you a quick diagram of what we're looking at here. So we have an externally facing net. You don't really see that going on. We have the DUTS IP address comes up as this. So we know what CDRouter is doing with it, and then we have these other servers that are out there that the DUT is communicating with, and we know that they're out on the internet. And then we have our CDRouter simulated DNS servers, and then the simulated FTP service. So again, what we're doing here is routing the test and application traffic separately. So this lets us replicate the benefits of closed loop testing, that is isolation, consistency, and ease of use. And it lets us apply them to situations where the device under test needs access to these external resources. So CDRouter does this by recognizing which traffic is destined to one of its own simulated resources and then routing any other traffic to an externally facing interface. Now, the only caveat to this is behind a net, so inbound connections are limited. So you could use this setup to allow a device to communicate with something like a real-world ACS, for example, but it would require the usual systems for getting around NAT if you wanted connection requests to work. So you'd have to use STUN or XMPP or something else. So what are some of the test exercises that you want to focus on when you're testing these cloud dependent devices? Probably one of the most important things is security, and that includes making sure that whatever you've built or your vendor has built into their solution that's communicating with these outside resources, that communication is secure. We've actually seen a lot of cases with the devices that are out there, or newer devices or kind of prototyped things that this is not the case, and it's a very important practice, and it's important that that when you're qualifying the stuff that you're purchasing to put in your network, that they're doing this kind of stuff correctly. Also doing data validation and that kind of thing on the API calls, but also firewall scanning, so making sure that the device isn't revealing any of its open ports, things, because if this is some proprietary protocol and there are inbound API calls being made on the device, you want to make sure that those are either whitelisted or locked down. You also want to test to make sure that anything that you're doing with your test traffic that would be simulating user activity or other services doesn't interfere with the things that the device needs to do, that are in the cloud, the things that it needs to communicate, so that your bootstrap isn't interrupted, or your ongoing activity isn't interrupted. Something like starting a firmware download and then having CDRouter run its WAN connection renumbering test and making sure that the firmware download continues and is successful. Also, if your device as part of its service has some statistical reporting, making sure that those statistics are actually updated when activity occurs. So as you're running your CDRouter tests, you're going to be doing a lot of different application tests and having real things going on, or just even packet counts, and you want to make sure that if the device is reporting that to some cloud service, that it's actually working and being updated. Also, if you have any proprietary diagnostic tests that are running, that those are able to operate while other stuff is going on. And then also removing connection sharing and making sure the device will function even if it doesn't have access to the WAN. So, in the event that it loses connection to these external resources, what happens to the behavior, because the end user is probably going to end up experiencing that. All right, so that's the basics of how we test these cloud-dependent devices. And here's a couple more resources to know more about that, including an overview of our ICS add-on, the user guide for it, and also if you do want to kind of play around with those advanced ladder diagrams and some of the other things that CloudShark can do, you can find it at cloudshark.org. All right, well, thanks everybody. That was short and straightforward, but we wanted to kind of get the point across that this is a possibility in CDRouter if you are deploying or building these kinds of devices. So if you have any questions, or if you have an existing license and you want to try to experiment with ICS, feel free to contact us either at support or sales. And like I said, this will work with the other CDRouter add-ons too. So if you have IPv6, that'll work. If you do want to run TR69 tests while you have this stuff going on, then that'll work too. And so, yeah, if you have any questions, feel free to email us at support@qacafe.com or sales@qacafe.com.